Reversing the rules for special products provides us with shortcuts for factoring certain polynomials. Let's take a look. Consider the following binomial times trinomial. Using distributive property of the trinomial times each term in the binomial results in the following, which further requires another distributive property for each one of these two multiplications, resulting in the following expression. Combining like terms, we see that a squared b has an additive inverse, which cancels out, and an ab squared has an additive inverse, canceling out, leaving the product of these two polynomials of a to the third power plus b to the third power, which we refer to as the sum of cubes. To factor a sum of cubes, we will reverse this special multiplication. In this slide, they're asking whether the binomial x to the third plus 8 is a sum of cubes. It must meet the following criteria. Is the first term a perfect cube? X to the third power is x cubed. Is the last term a perfect cube? Since 8 is 2 to the third power, it also meets the criteria. And lastly, the terms are a sum. The three criteria for this binomial have been met to classify it as a sum of cubes. To factor it then, since we already have established that 8 is equivalent to 2 to the third power, we can reverse this special multiplication process and factor the sum of cubes using the cube root of the first term and the cube root of the second term to identify the roots to factor this sum of cubes. A plus b for this particular binomial is x plus 2, the cube root of the first plus the cube root of the second, times square of the first term, opposite sign, product of AB, which is 2 times x for this particular binomial, plus b squared, and 2 squared is 4. It should be worth noted that this trinomial is prime and cannot be broken down further. Here we have another example factoring this. Is it a sum of cubes? Sure enough, x to the third plus 5 to the third is equivalent to x to the third plus 125. Since it's a sum of cubes, we'll reverse the multiplication following the format of the cube root of the first plus the cube root of the second times square of the first, opposite sign, product of the first and second, 5 times x, plus the square of the second term. Here we have one last example. 2y to the third plus 54 certainly isn't cubes, but we do need to remember the possibility of having a greatest common factor, and that is the case. Factoring out 2 from each term results in the following binomial, which is a sum of cubes, since y to the third is y to the power of 3, and 27 is 3 to the third power. Factoring this sum of cubes, we reverse our special multiplication. Following the format, we will have our greatest common factor times cube root of the first plus cube root of the second, times the quantity square of the first term, opposite sign of the addition, so we have a minus, product of the cube roots, 3 times y, plus square of the second term, 3 squared is 9, and we have it factored completely.